bolting neutral lugs separately to the CT cabinet, even if they are a few inches apart, is considered objectionable current flow. This is known as cross-compounding and can cause potential safety hazards. When the neutral lug is bolted separately, the current flows through the CT cabinet instead of the neutral conductor. This creates an unnecessary path for current flow, which can lead to increased resistance and voltage drop, overheating of the CT cabinet, and interference with the accuracy of the CT measurements. In the event of a ground fault, the high current flowing through the CT cabinet can cause electrical arcing. This can damage the cabinet and create a fire hazard. Neutral lugs should be connected together using the same bolt or hardware, ensuring that there is a continuous path for neutral current flow. The lug assembly should be bolted securely to the CT cabinet, ensuring a good electrical connection. The neutral conductor should be connected to the lug assembly, completing the neutral path. Improper installation of neutral lugs can compromise the safety and accuracy of the electrical system. The objectionable currents can lead to reduced electrical efficiency, damage to equipment, and increased risk of electrical accidents. It is crucial to follow proper electrical installation practices to ensure a safe and reliable electrical system. Bolting neutral lugs separately to the CT cabinet is an improper practice that can lead to objectionable currents. Therefore, it is essential to connect the neutral lugs together using the same hardware to provide a continuous path for neutral current flow. When dealing with electrical systems, it's crucial to prioritize safety and adherence to established codes and standards. A proper installation of components, like neutral lugs in a CT cabinet, can have significant consequences, ranging from reduced efficiency to potential safety hazards such as electrical fires. The fundamental principle behind proper neutral lug installation is to provide a dedicated and continuous path for neutral current. This path should minimize impedance and prevent current from flowing through unintended conductive materials, like the CT cabinet itself. When neutral lugs are bolted separately to the cabinet, even if they are in close proximity, the cabinet becomes part of the neutral current path. This is problematic for several reasons. Firstly, the CT cabinet is not designed to carry significant neutral current. Its conductive properties in cross-sectional area are not optimized for this purpose, leading to increased resistance. This increased resistance results in voltage drop along the current path, which can affect the performance of connected equipment. Secondly, the unintended current flow through the cabinet can cause overheating. Electrical resistance generates heat, and if the cabinet is not adequately sized to dissipate this heat, it can lead to insulation breakdown and even fire. Thirdly, the presence of neutral current in the CT cabinet can interfere with the accuracy of the current transformers CT housed within. CT are precision devices that measure current flowing through conductors. Extraneous current flowing through the cabinet can induce magnetic fields that distort the CT measurements, leading to inaccurate readings and potential problems with protective relaying and metering. In the event of a ground fault, where a live conductor comes into contact with a grounded surface, the consequences of improper neutral lug installation can be even more severe. The high fault current will seek the path of least resistance back to the source, and if the CT cabinet is part of that path, it can experience a massive surge of current. This can lead to rapid and intense heating, causing electrical arcing. Electrical arcing is a dangerous phenomenon that can ignite flammable materials and cause severe burns. To ensure safe and reliable operation, neutral lugs must be installed in a way that provides a dedicated and continuous neutral path. This is typically achieved by connecting the lugs together using a common bolt or hardware, creating a single point of connection. This connection should be mechanically sound and provide a low-resistance electrical path. The lug assembly should then be securely bolted to the CT cabinet, ensuring a good electrical connection between the lug assembly and the cabinet grounding system. The neutral conductor should be connected to the lug assembly, completing the neutral path. By following these practices, you can prevent objectionable current from flowing through the CT cabinet and minimize the risk of electrical hazards. The NEC, or National Electrical Code, provides detailed guidelines for grounding and bonding electrical systems, including requirements for neutral conductors and equipment grounding. Article 250 of the NEC covers grounding and bonding, and it's essential to consult this article for specific requirements related to neutral lug installation and CT cabinet grounding. It's also important to be aware of local electrical codes and regulations, as these may have additional requirements beyond the NEC. When working with electrical systems, it's always best to consult with a qualified electrical professional to ensure that the installation is safe and compliant with all applicable codes and standards. Regular inspections and maintenance of electrical systems are also crucial for identifying and correcting any potential problems before they lead to accidents or equipment damage. In summary, proper neutral lug installation in CT cabinets is essential for ensuring the safe and reliable operation of electrical systems. By connecting the neutral lugs together and providing a dedicated neutral path, you can prevent objectionable current flow, minimize the risk of electrical hazards, and maintain the accuracy of CT measurements. Always consult with a qualified electrical professional and follow applicable codes and standards when working with electrical systems. Understanding the principles behind grounding and bonding is crucial for any electrician or electrical engineer. The purpose of grounding is to provide a low impedance path for fault current to return to the source, allowing protective devices such as circuit breakers or fuses to quickly clear the fault. Bonding, on the other hand, is the process of connecting all non-current carrying metal parts of an electrical system together to create an equipotential plane. This ensures that there are no voltage differences between these parts, which can prevent electric shock hazards. The combination of grounding and bonding provides a comprehensive safety system that protects people and equipment from electrical hazards. In the context of neutral lug installation, proper grounding and bonding are essential for preventing objectionable current flow and ensuring that the CT cabinet is at the same potential as the neutral conductor. This minimizes the risk of electrical shock and prevents interference with CT measurements. When installing neutral lugs, it's important to use appropriate hardware and tools. The lug should be sized correctly for the conductor being used, and the connections should be made tightly and securely. The use of antioxidant compounds can help to prevent corrosion at the connections, which can increase resistance and lead to overheating. It's also important to inspect the CT cabinet for any signs of damage or corrosion before installing the neutral lugs. Any damaged or corroded part should be replaced to ensure a good electrical connection. In addition to proper installation techniques, it's also important to follow safe work practices when working with electrical systems. Always to energize the circuit before working on any electrical components, and use appropriate personal protective equipment PPE such as gloves and safety glasses. Never work alone, and always have a qualified person available to provide assistance in case of an emergency. Electrical safety is everyone's responsibility, and by following these guidelines, you can help to prevent electrical accidents and ensure a safe working environment. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrical professional before working on any electrical systems. Let's delve deeper into the specific issues that arise from improper neutral lug installation and how they impact the overall electrical system. Firstly, consider the effect on power quality. Objectionable neutral current flowing through the CT cabinet introduces harmonic distortion into the system. Harmonics are unwanted frequencies that can cause a variety of problems, including overheating of transformers and conductors, malfunction of sensitive electronic equipment, and increased energy losses. The presence of harmonics can also make it difficult to accurately measure power consumption, leading to billing errors. Secondly, consider the impact on equipment lifespan. The increased resistance and voltage drop caused by improper neutral lug installation can lead to premature failure of connected equipment. Motors, for example, may overheat and fail if they are not receiving the correct voltage. Electronic equipment may also be damaged by voltage fluctuations and harmonic distortion. By ensuring proper neutral lug installation, you can help to extend the lifespan of your electrical equipment and reduce maintenance costs. Thirdly, consider the potential for electromagnetic interference (EMI). Objectionable neutral current flowing through the CT cabinet can generate electromagnetic fields that interfere with the operation of nearby electronic equipment. This can cause problems with communication systems, control systems, and other sensitive devices. By minimizing neutral current flow through the cabinet, you can reduce the risk of EMI and ensure the reliable operation of your electronic equipment. Now, let's discuss the different types of neutral lugs that are available and how to choose the right one for your application. There are two main types of neutral lugs: mechanical lugs and compression lugs. Mechanical lugs are typically used for smaller conductors and are tightened using a wrench or screwdriver. Compression lugs are used for larger conductors and require a special crimping tool to install. Compression lugs provide a more reliable connection than mechanical lugs, but they are also more expensive and require specialized tools. When choosing a neutral lug, it's important to consider the size and type of conductor being used, the current carrying capacity of the lug, and the environmental conditions. The lug should be made of a corrosion-resistant material such as copper or aluminum and should be suitable for the temperature range in which it will be used. It's also important to ensure that the lug is listed and labeled by a recognized testing laboratory such as Underwriters Laboratories UL or Canadian Standards Association CSA. This ensures that the lug has been tested and meets applicable safety standards. When installing neutral lugs, it's important to follow the manufacturer's instructions carefully. The lug should be tightened to the specified torque using a calibrated torque wrench. Over-tightening can damage the lug or conductor, while under-tightening can result in a loose connection. It's also important to inspect the connection regularly to ensure that it remains tight and corrosion-free. If you notice any signs of damage or corrosion, the lug should be replaced immediately. In addition to proper installation and maintenance, it's also important to protect neutral lugs from physical damage. The lugs should be installed in a location where they are not likely to be bumped or crushed. If the lugs are exposed to the elements, they should be protected by a weatherproof enclosure. By taking these precautions, you can help to ensure that your neutral lugs provide a safe and reliable connection for many years. Remember, proper neutral lug installation is not just a matter of following code requirements, it's also a matter of protecting people and equipment from electrical hazards. By understanding the principles behind grounding and bonding, choosing the right lugs, and following safe work practices, you can help to create a safe and reliable electrical system. It is critical that the electrical worker verify that the neutral connection is solid and reliable. A loose connection can create heat that will melt the conductor. This can lead to arcing and a fire. The electrical worker should also verify that the neutral conductor is properly sized for the load. An undersized neutral conductor can overheat and cause a fire. The neutral conductor should be the same size as the ungrounded conductors. The electrical worker should also verify that the neutral conductor is properly grounded. A properly grounded neutral conductor will help to protect people from electrical shock. The neutral conductor should be grounded to the grounding electrode system. The grounding electrode system should consist of a grounding electrode conductor, a grounding electrode, and a bonding jumper. The grounding electrode conductor should be connected to the grounding electrode. The grounding electrode should be a metal rod, pipe, or plate that is buried in the ground. The bonding jumper should be connected to the grounding electrode system and to the metal parts of the electrical system. The metal parts of the electrical system include the metal enclosures, the metal conduit, and the metal equipment. The bonding jumper should be sized according to the NEC. The NEC provides tables that list the minimum size of the bonding jumper. The electrical worker should also verify that the neutral conductor is properly insulated. A properly insulated neutral conductor will help to prevent electrical shock. The neutral conductor should be insulated with a white or grey insulation. The insulation should be rated for the voltage of the electrical system. The electrical worker should also verify that the neutral conductor is properly protected from physical damage. The neutral conductor should be protected from physical damage by being installed in conduit, raceway, or cable. The conduit, raceway, or cable should be properly secured to the building structure. The electrical worker should also verify that the neutral conductor is properly identified. The neutral conductor should be identified by being marked with a white or grey marking. The marking should be visible at all points along the conductor. The electrical worker should also verify that the neutral conductor is properly terminated. The neutral conductor should be terminated at a neutral busbar or neutral terminal block. The neutral busbar or neutral terminal block should be properly grounded. The electrical worker should also verify that the neutral conductor is properly tested. The neutral conductor should be tested for continuity, insulation resistance, and ground resistance. The test should be performed using a qualified testing instrument. The results of the test should be recorded and maintained. The electrical worker should also verify that the neutral conductor is properly maintained. The neutral conductor should be inspected regularly for signs of damage or deterioration. Any damage or deterioration should be repaired or replaced immediately. The electrical worker should also verify that the neutral conductor is properly documented. The documentation should include the size of the conductor, the type of insulation, a location of the conductor, and the results of the tests. The documentation should be kept in a safe place and should be readily available. These are some of the things that an electrical worker should do to verify that the neutral conductor is properly installed. By following these guidelines, you can help to ensure that your electrical system is safe and reliable.